Good evening, students. Today we will discuss the second part of the lesson, that is magnetic effects of electric current. So here I have taken one compass. I think you all are very familiar with this device. This is known as compass. So with this one we find out the direction of earth. So different directions the earth can be found out with the help of this device. It's a very simple and small device known as compass. So here I am keeping it in to find out the different directions. So in my home, this side is north. If you see, this side is north, and this side is west, and this side is south, and this is our east. So four different directions are here. In the compass is showing these four directions. So we'll see how this compass deflects when it is brought near to any magnet. So when a magnet is brought near to the compass, what changes we can see in the needle or in the compass. So let's bring one piece of magnet. I have a piece of bar magnet. I am bringing it near to the compass. Let's see what happens. So when I bring it near to this is the bar needle. This is the bar magnet we have, and this side is marked with, means this is the north pole of the magnet, and this one is no marking is there, means it is the south pole. So as we know, in class 6 we studied about magnets. So magnets is two poles, south pole and north pole. So north pole and south pole. So when I bring this magnet near to this compass, what happens? You see, in the bar magnet, the needle of the compass is deflecting. So here I bring it near to it, it deflects. So deflections can be seen in the needle of the compass when it is brought near to any magnetic material or any piece of magnet. So this happens when a magnet is brought near to any compass. Why it happens? Because the needle of the compass is also made of magnet. So when two different types of different poles of two magnets come across, they try to repel each other, and when similar poles come across, it tries to repel each other. When dissimilar or unlike poles come across, they try to attract each other. So if you see here, this is our north pole. So it is this is north pole, and this side of the compass is south. So south pole. So south pole of the needle and the north pole of the bar magnet are attracting each other. It is constant, it's no deflection, means these two sides, this north pole of the bar magnet and south pole of the compass are attracting each other. Similar thing can be seen on the opposite direction. If I bring it this side, you see here, this is the south pole of the bar magnet, and this side is this red marked side is the north pole of the needle of the compass. So they are attracting each other. So if I bring it, you see this side is going that side, means similar like poles attract repel each other, and unlike poles attract each other. So you have seen this one, means any magnetic material when it is brought near to any compass needle, it deflects. We can see the deflection in the compass. So we will see whether anything occurs when we bring current near to the compass. So let's remove the bar magnet from the compass, so we can get the exact result. If this result is also, some errors are there because my mobile phone is also near to that. Mobile phone also contains some magnets, so in the result is not accurate. So we can get some small deflection when mobile phone is also brought near to the compass. So I have prepared one small circuit. So we have the cell here, so and we have the small cell, and we have that light bulb, and we have a key switch. So these are the different devices. Let's bring it here. So you see, when I bring this one near to this electrical wire, so when I turn on the switch, what happens? The bulb will glow, and you see the electric current is passing through the wire to this one. This side is the positive side of the battery, so the current will be flowing from this positive wire to this yellow wire. It will be coming to the bulb, and it will be going to the switch, and it will again going to the negative terminal of the battery. So when I see, if I bring near to this wire, means through the wire electric current is passing now. If I turn off, you see when I turn on, let's when I turn on, you can see a small deflection once again. So let's keep it on the top of this one. Yeah, so it's now off. This one is constant, means it's not moving. So when I turn on, you see a small deflection. Yeah, can you see it? Can you observe that one? So when I turn off, means there is no deflection in the compass needle. When I turn on the switch, you see a small deflection. Means when the current is flowing through the wire, a small deflection can be seen in the compass needle. Yeah, when I turn off, it is again moved. Its small deflection was seen. So this is what happens actually. So if we talk about theoretically, so this is the practical demonstration. So when electric current passes through any electrical wire or through any conductor, it produces electric field. So it produces magnetic field around it. So when electricity passes through any conductor, it produces magnetic field or around the wire or around the conductor. So similarly, when we saw when magnet was brought near to it, it deflect. Similarly, when electric current also passed, it deflect, means through the wire when electric current is passed, it produces magnetic field. Through because of that one, we can see the deflection on the compass needle. Good evening, students. Now we will discuss about one of the very interesting concept of this lesson, that is about solenoid and electromagnets. So what is solenoid? First we will understand. So this one we will call as a solenoid. So it's a piece of copper wire and it is isolated with some plastic. So this is the normal wire that we use in our homes. So what I did, I just made spiral it or make it or made it in the form of a coil around any cylindrical body. So when copper wire or when a conductor which is isolated with the help of some plastic or with polythene or with anything, with an isolated with some isolator, and when we spiral or when we give the wire or the conductor in the circular shape or in a coil shape like in a spring, then this wire now we will consider as a solenoid. So this is known as solenoid. I will give the exact or perfect definition of this one in the notes. So you just understand this: when the electric wire is coiled in the form of some spring, it is known as solenoid. So what I will take this piece of iron now. This is a conductor and this is a very good conductor iron. So I will check whether it attracts any material or not, any ferromagnetic material or not. So let me bring anything which is ferromagnetic object once again. So I have this tester and the tip of the tester, you see it is ferromagnetic material, means it is attracted by the magnet. So I have the bar magnet and it is attracted by the bar magnet. You see it is attracted. So it's a ferromagnetic material. We'll see once again. So when I bring this to near to it, there is no any attraction or repulsion between these two objects. So this is a ferromagnetic material and it's also a ferromagnetic material, but they are not attracting each other. So now we will do one thing. Let's see. Okay. So when I pass electricity through this solenoid and I will place this conductor inside the solenoid, I have placed this one inside the solenoid and I will pass electricity through this wire and then we will observe what happens. Okay, now I have connected this one the solenoid. We have the solenoid and under this or inside the solenoid we have the conductor, a piece of iron or iron nail I have, and I have connected it with the circuit. So I have connected this with the circuit. This positive side of this wire or the positive terminal of the battery is connected with this wire and it is going like this and it is coming to the bulb, and I have the bulb. and then from the bulb one end is connected to the switch, another end of the switch is connected to this solenoid, which is coming to this negative end terminal of the battery. Means it's a complete circuit. And when I turn on the switch, you see the electricity is passing through the wire or circuit. So from the positive, the electrons are flowing, or the electricity is flowing from this positive terminal to this bulb, and from the bulb to the switch, and from here it is moving through this into the battery again. So what happens when I pass the electricity? Before passing the electricity, let's test with the tester. So if I test, you see there is no any attraction between the two objects. You see there is no any attraction. But when I pass the electricity, you can see a small difference. Now you see it is trying to pull the thing. There is a small attraction between the objects. This solenoid, or the material which is present inside the solenoid, is acting like a magnet. The weight of the iron is very heavy, so it's not pulling it, but I can feel the attraction. You can see it is trying to pull out the material. Means there is attraction between the two things. You can see it. That force is not that great, but there is a small force which can be felt by touching it. You can see it. Yeah, so this is all about that solenoid and all. So when electricity is passed through any solenoid, the material which is present inside the solenoid becomes magnetic, or acts like magnet. So that's why it is attracting the ferromagnetic objects. So the magnet which is produced by this process is known as electromagnet. With the help of electricity, we prepare this type of magnet, and so hence this type of magnets are known as electromagnets. So this is all about electromagnet and solenoid, and we are left with only one topic, that is electric well. So I will prepare a separate video for that, and thank you for watching the video with so much of patience.